And I'm here to introduce our next speaker. His name is Charles Frye from Modal Labs. I'm sure you have heard DevOps. Now we have MLOps, LLMOps, AIOps, so many others. So Charles is going to introduce those for us. Over to you, Charles.
All right, that's audible? Seems like that's audible. Hey, everybody. Yeah, so my name is Charles. I did a PhD on optimizing neural networks at Berkeley, then worked on MLOps at Weights and Biases, and now I work at Modal, serverless infrastructure company. And in the run-up, what I think is exciting about this AI QCon is the MLOps community has been sort of like in the trenches, making hard to like complex systems work and turning them into products. And in the last year or two, there's been this huge inrush of like a new collection of software engineers and engineers who want to do the same thing with a new, slightly different type of system based off of pre-trained language models. And so they have gotten excited about the idea of like AIOps, LLMOps, AgentOps. And this is like, people are encountering a bunch of problems and like running into like, oh, I can set up a demo and that works like really well for like on Twitter, but then like I can't turn that into an actual product. And so the interest in this AI ops discipline is that it promises to like actually like consistently improve production outcomes from these systems. And because some of these people haven't been in the field as long as lots of us in the MLOps community have been, they're like sort of repeating a lot of the mistakes from the like MLOps period. And like it actually turns out that LLMs are not the first piece of like opaque, hard to control software that people have tried to get to work. And nor is it the first time that people have tried to get a complex system that they don't have full control over to like deliver value. So there's actually kind of like a half century of operations, research, and disciplines that we can learn from. So I wanted to kind of like walk through that really quickly in this talk. So I'm going to talk about like everything from AI ops back to like, you know, running factories and try and draw lessons for like how to make your chatbot not suck. So right now with AI ops, the thing people are most excited about, the thing that people like are raising money over is evals. So this virtuous cycle that Hamel Hussein posted in his Your Chatbot Needs Evals blog post. He was talking about how you had this like this cycle of improvement where you would like make a model, you put a model out there, you evaluate, you curate good evaluations for that model, you put it out into production, the model is better, that generates additional data, and that allows you to like kind of push this loop forward of continual improvement. The center of that is this like evaluation and curation, and a lot of people talk about evaluation and curation because of its centrality, but really it's like the thing it is the center of is the most important part, this like iterative loop of improvement. And it's this like sort of iterative loop of improvement that we're gonna see sort of repeated throughout these different disciplines, each time with a slightly different emphasis. So there's been a number of kind of like key insights that even in the like short period that people have been trying to operationalize foundation models that we've seen already. Number one, simplifying tasks for evaluation rather than having like if you have a summarization task, it's very hard to evaluate whether a summary is good or not. But you can evaluate whether it's 100 characters long or longer. You can evaluate like whether it contains a particular proper noun or not. So if you simplify it down to a binary classification, you'll have an easier time. Another key insight that I think people who've been working in the ML field will find unsurprising is that there's a lot of kind of like janky software out there to support the use of LLMs. There's like fresh and hot, open source French software that might fail more frequently than you would like. And so people working on AI engineering and LLMOps have found that they need to like trust no one. Look very carefully. Look directly at the tokens coming in and out of your model. Look directly at the tensors coming in and out of your model. And then lastly, that's my calendar, and that's Whisper AI. By the way, it's actually great speech to text Whisper, but that's not what I'm trying to show right now. Last thing, like maybe the most important or surprising novel insight with AIOps relative to MLOps is that synthetic data is extremely powerful within like certain limits. So when you can take these pre-trained like large-scale models and use them to generate new data that you can use to improve that model, improve your application, or to like train an entirely new model. I think one of the reasons this is most powerful is because fine-tuning on synthetic data is a very well-posed ML problem. You have a data generating process in the form of a model, and you just want to copy that data generating process into a new form. And that's a very well-posed ML problem compared to the other things that people try and do with ML, where your data generation process is in the control of users, or it's some sensors out in the natural world. So synthetic data is really useful for sort of kick-starting that iterative loop of improvement, because now you don't need data in order to get started. You can use, you don't need to go out and collect data in some expensive annotation project. You can just start with synthetic data. And usually, it's not fully synthetic, it's some semi-synthetic thing where you get some easy to acquire data and then you enrich it with additional synthetic data. So it doesn't solve every problem, but it solves many of them. So those are all sort of kind of insights and a figure from the field of AIOps and LLMOps. But this stuff is not entirely new. I saw a lot of people nodding along because some of these same ideas show up in MLOps, right? So looking back at Shreya Shankar's paper on operationalizing machine learning, that also centered on one of these loops. Figure 1 was a loop that looked very similar. There's more focus on data collection here. Data collection is at the beginning as opposed to partway through with foundation models, but it's a very similar loop. This is also the core loop that when I was teaching full stack deep learning with Josh Tobin and Sergey Karyev, the core thing we tried to teach people about going from research to production with neural networks was that you needed to find a way to set up a loop like this where you are able to collect additional data from the behavior of your users. So there are a couple key insights from MLOps that I think are kind of easy to lose sight of when a new exciting model or domain comes around. One of the most important ones is that pipelines are what matter, not models, right? If you have a set of weights, that's going to be useful for a while, but at some point, weights that produce inferences are very fungible. You can swap them out with a different program that has the same input and output types, and so the weights don't really store value. What stores value is the system that allows you to produce a new model when new data comes in, or that allows you to determine that a new model that just came out is actually better. So this was an important part of what made MLOps successful. At the same time, there's kind of a counterpoint, which is people tried to get continual learning loops working with ML, where this entire sort of circle would spin itself automatically. Andre Karpathy's Operation Vacation. And given that everybody here is not on vacation, this didn't actually really work out. So full automation of this loop is really, really hard. So people reaching to be oh, I'll just use LLMs as a judge and they'll evaluate my LLM prompts and they'll write a new prompt and then that will run and then it'll judge iteratively. This is a suggestion we won't be able to pull that off. And then finally, I think the most important thing that needed to be communicated from MLOps that was novel relative to other ops disciplines was the importance of looking closely at data. So everybody from OpenAI researchers to folks like Shreya Shankar were saying the most important thing is to spend time actually looking at the inputs and outputs of models. And doing things like making cleaning data and looking at data part of your interview process, making it part of your stand-up or on-call for your engineering team, that everybody has to sit and look at data for 1 hour a week. These are the kinds of practices that really good MLOps teams adopted, and they'll transfer directly to building on foundation models. But a lot of the ideas in MLOps, if you were around building software in the early 2010s, struck people as familiar because they were kind of just the ideas of DevOps reapplied. So DevOps before MLOps was about sort of closing the loop between the release of software in the world and the development of software internally, operationalization of software and IT teams and development teams. And it had its own loop of continual improvement. They also ran into the problem that like fully automating software systems was really, really hard. You don't really want like 0-click deploys. You always want like a person deciding to do a merge, or a person like deciding that now is like time to deploy, or now is time to include this. And so like again, full automation, very difficult. Another one of the like bugbears of DevOps was the difference between your testing environment and your development environment and your prod environment. And this is also shown up in MLOps and LLMOps as like differences between the data that you have in your testing and evaluation and in production. So fun, like we get to have the fun of both having the same software 1.0 test prod skew of like versions being slightly different, and like, oh yeah, we changed the tokenizer behavior and now it tokenizes differently, and data being different between those two places. And then lastly, maybe the controversial insight of DevOps was that the way to solve that problem is to test in production. And the best teams who did testing in production were very clear that this worked only if you could, like, from the information you retrieved in production, from the like traces you got in production, you could turn those into bug fixes directly without needing to go and spin up a separate dev environment and do your debugging there. We're still short of that in ML. We're still short of that in building on foundation models. We have monitoring without observability or controllability. So that's an open problem. People are working on that with MLOps tooling. Then DevOps is like, as a discipline, was not entirely new. It was like directly inspired by the like lean movement. So DevOps, like the people building it originally were very clear that they were applying the ideas of lean startup and lean production to development. So you can find the exact same loop in something like lean startup. There's a bunch of insights from that we can carry over. The minimum viable product is like maybe the most popular one. It's like the idea is try and find something simpler than the whole system you want to build to at least get this wheel turning in its first iteration. Like have a human do the task instead of an LLM, or have software 1.0 do the task poorly instead of an LLM. Maybe a deeper insight from Lean Startup was that metrics are good when they are accessible, auditable, and actionable. Accessible means like everybody who interacts with the system is able to see those metrics. Auditable means that they can see how those metrics were calculated. These two things, I think some of the early like LLMOps tooling that we're seeing, like Langsmith from LangChain and Wanbi Weave, have targeted these things. Weave focusing on auditability and Langsmith focusing on accessibility, but we're still missing actionability, the ability to turn these insights into direct model improvements. So maybe it's mechanistic interpretability and control vectors, maybe it's better continual learning algorithms and prompt optimization, but something needs to come in here and improve the actionability of these insights to make them like actually like have them be good metrics useful for turning this loop. And lastly, like the lean startup movement, like despite what people in Northern California will tell you, did not originate in Silicon Valley. It came from Toyota. So the people working on DevOps were clear that they were inspired by manufacturing, physical manufacturing, not like computer science and mathematics. And Eric Ries in the Lean Startup is very clear that what made everything click for him on entrepreneurship and made it easy to understand like what insights he had were generalizable was studying the Toyota production system and lean manufacturing. And like this manufacturing system was like very critical to like, it's like at the scale of Ford's assembly line, but like less well known, I think. And at the core of that system is also a loop of continual improvement. A lot of the insights from the Toyota production system, they aren't necessarily unique. Like genchi genbustu, the idea of looking at like real things in real places on factory floors, is like, that's not like the translation of that is look at the data, look at the actual data in production. So we've already seen that, but it's nice to see it repeated in this like very different context. I guess maybe the last thing I would say on it is that one of the key components of the Toyota production system was the idea of single minute exchange of die. Like swapping out some of the heavy like key components that determine whether a machine makes widget A or widget B. That could take hours in old production systems oriented to large batches. And Toyota's insight was that if they changed the way that they oriented their system, they could switch these dies over in minutes instead of hours. And that allowed them to be directly responsible to like consumer demand. So somebody says, I want like a Toyota Corolla with the with this special piece added, and then that gets propagated back to the factory and turned into a machine makes that part in response to that demand. And despite the like much greater complexity, the much greater opacity, and the much lower controllability of the system they were working with, they were able to achieve that level of responsiveness to actual consumer demand. And so that's the sort of like the guiding star that I have in thinking about how to build LLM applications, is able to achieve this sort of like, single minute exchange of prompt, this immediate responsibility of my application to consumer demand. So that's it. That's my TED Talk. I'll say 2 seconds at the end. I work at an infrastructure company, Modal. We build infrastructure that helps support these kinds of applications and these kinds of pipelines. It's like AWS Lambda, but if it was good and had GPUs. So yeah, modal.com, check us out. Thank you.
Thank you. We have time for 1 to 2 questions if anybody has.
Oh, nice.
I am also a huge fan of Toyota. So one thing about the Toyota system is that they allow anyone on the product line, regardless of hierarchy, to stop the assembly line. How does that work out in a software system where revenue and continual revenue is key?
Yeah, I would say that the equivalent of the on-done chord in DevOps is like a red X on a PR means you don't deploy. I think the challenge with that is that nobody wants their deploy blocked on a flaky test. And right now, the tests that we have for LLMs are generally fairly flaky. Like if you set a threshold of 0.75 on some metric and then you block a release because it's 0.74, like nobody's happy when that happens. So I think that's one reason why it's harder to do this. I think maybe this sort of thing I would page on for these or block deploy on is things like safety or like, maybe Google should have pulled the and-on cord when they told people to eat pizza with glue. So like, that's what I think is the equivalent of that, whereas these sort of the test equivalents that are checking bulk performance metrics aren't worth like shutting down the production line over.
One more question before we take a short break.
I really love the thing about AIOps being part of ML and then Dev and then Lean Toyota. In like the new age of Gen AI, the data flywheel, and you go back to model retraining in MLOps. So we already use large language models, which nobody actually is retraining the entire thing. We either do RAG or fine tuning. So how does the landscape change when like things don't work as expected in production? What are some of the things that are the challenges currently and the open problems in which how we can optimize this space?
Yeah, in some ways it feels like it feels like a harder problem because you don't control the production of this initial artifact, like the like pre-trained weights that you're using. But in some ways that actually makes the problem easier because like a huge component of your ML problem was the kind of stuff that could be learned from web scale text. And like if you were producing that artifact from scratch, you'd be tempted to like always go all the way back to the beginning of training and start over every time you had a problem in production. So I think it actually is like a good thing that we are forced to we're essentially forced to cut off at RAG systems, at fine tuning, at LoRa's, or at like control vectors, as opposed to going all the way back. Because I feel like the majority of your problems can be solved by those changes. For the problems that can't be solved by those changes, that actually need like a boost in the fundamental model capabilities, it's like you kind of have to wait for new models to come out from the core model providers. And then the thing that makes you able to do that quickly is an evaluation chassis that makes you confident that the model is actually better. So like Claude 3.5 has great Twitter PR and good vibes, but like does that actually mean that you should use it to replace 4.0 in production? If you have a solid evaluation chassis that gives you confidence for making every other change that you do to prompts or fine tuning or what have you, that is the very same chassis should, if constructed well, also allow you to swap models in and out. And that gets you back that outermost loop of improvement.